Alright, today in class we learned how to solve systems of equations using the elimination method. We've learned two other ways how to solve systems of equations. The first one is by graphing, the second one was by substitution, and we will follow those today with the elimination method. So we're going to solve systems algebraically by using the elimination method, and we'll also determine whether the solution is 1, infinite, or no solution. Okay, the elimination method, the first step I'll ask you to do is choose a variable to eliminate. Sometimes that's really easy to decide, other times it gets a little bit harder. The second step is to create opposite coefficients. Now, coefficients are the numbers in front of the variables. Once you've created opposite coefficients, you will add the two equations. The third step, solve for the remaining variable. So when you add them, you will eliminate a variable and you'll have one variable left. You will solve for that variable. Once you have that variable solved, you will use step 4 by substituting it into either equation and solving for that remaining variable. At that point, you will solve for both variables, and you can check your solution by putting it into both equations to make sure it works for both. So we're going to solve this by elimination. You're going to look at these and decide which variable can I create opposite coefficients. Right now, the x's are exactly the same. They both have a coefficient of 2, but we don't want them to be the same. We want them to be opposite. So we can create opposite coefficients by changing the sign here, but once we do that to 1, we have to do it to all 3. So I'm going to change all 3. I'm going to draw that addition line and then add down. So I have a 2x minus a 2x. That eliminates, and that's the whole purpose of doing this. So then we're left with 1y minus 7y gives you a negative 6y equals 6 minus 12 is negative 6. To solve this, we divide by negative 6. That divides out on the left, and you get y equals 1. We're halfway done. You have one value, you have the y value. From here, you're going to choose to substitute that into either equation. I like to go back to an original equation, one I have not changed, so I'm going to pick the top equation, 2x plus y, and replace that y with 1, and then solve this for x. So we'll solve by subtracting 1, 2x equals 5, divide by 2, and x gives you 5 halves, or if you'd rather write it as 2 1/2, that's fine. So then we get one solution. It's located at 2 1/2, 1. Once you have the solution, you do want to check it in both the top and the bottom to make sure that it is accurate. We did that in class, and it did turn out to be accurate. Okay, here's your second problem. This one, it's a little bit harder to determine which ones we want to make the same. We could either make the x the same, we have some work to do, or the y's the same. But since both of them are different, then I would actually look at the signs and say, because these signs are opposite, I want to create the y's to be the same. So because I want the y's to be the same, I'm going to take this entire top equation and multiply by 5. I'm choosing 5 because I know that I can get these y's to be the same if I then multiply this one by a 4. So when I distribute that 5, one thing to remember is you have to take this 5 to all 3 terms. So we get the 5 times 7 is 35x, minus 5 times 4 is 20y, and 5 times 17 is 85. Then we do the bottom, we did multiply that 4 through. 4 times 3 gives us 12x, 4 times 5 is 20y, and 4 times 14 is 56. We're then going to add these. When we add them, hopefully we've created opposite coefficients. So we take the 35 plus the 12x gives us 47x. These y's right here, the negative 20 and the positive 20, will be eliminated. They subtract out, and this will equal 85 plus 56 is 141. We'd now divide by 47. X equals 3. Once you have this 3, you're going to go back to an original equation and solve. I'm going to use the bottom equation because there's no negative values in there, and I don't have to worry about any sign changes. And I substitute the 3 in for x. Now I'm going to solve this. 3 times 3 is 9, plus 5y equals 14. Then to solve that, you subtract 9. 9's go away. 5y equals 5. Divide by 5. 5's divide out, and y equals 1. So you have one solution at 3, 1. Again, you'll want to check those into the top and the bottom equation to make sure that this solution is correct. If it's not correct and does not check into both equations, then somewhere along the way you did your math wrong. So we have some special occasions, or special cases. So the first one we're going to look at, if I wanted to make the x's so that they were opposite coefficients, then I would take this second equation and I would multiply it by -2. This would give me my new equation, -6x minus 4y equals -2. Again, don't forget to distribute that 2 to all 3 pieces. And then the top one, 6x plus 4y equals -1. From here, we see that that eliminates. This one eliminates. You get 0 over here equals -3. Now, we can see that this is no solution because these two are not equal. So if you get into a situation where you add your two equations and both the variables drop out and you get a statement that is not equal. So again, if you get to this point where both variables subtract out and you get an inequality or a statement that is not true, then that means there's no solution. So for this one to work, I have a typo. I have to change this to a 2. So again, you're going to multiply this bottom one by -2 to eliminate these x values. And make sure when you do that you want to distribute this 2 to all 3 terms. It gives you the new equation, -6x minus 4y equals 2. I'm going to rewrite the top equation, which says 6x plus 4y equals -2, because I did make that change. Then what happens is these subtract out, you're left with 0 equals 0. 2 minus 2 is 0. If you get to this situation where you do have a true statement and you have no variables, that means you have infinite solutions because these two lines are exactly the same. Alright, word problems, our application problems. It says the drama club sold $200 worth of hot drinks. They sold 295 cups. If hot chocolate sells for 75 cents and coffee sells for 50 cents, how many of each did they sell? The first thing you're going to want to do when you get this type of a problem is you're going to want to identify your variables. So I'm going to do H is hot chocolate, and C equals coffee. And then I'm going to go back to my word problem and figure out what this means. It says they sold 295 cups. So together, hot chocolate and coffee, there were 295 cups. Then it says if hot chocolate sells for 75 cents each, I would go 75 cents for hot chocolate. And coffee sells for 50 cents, 50 cents for coffee. How many of each did they sell? But it says that they did sell $200 worth. Alright, once you have set up your system, you're going to decide by elimination how to solve this. So we can do multiple things here. One of my classes said, let's multiply the bottom one by -2. So if we distribute that -2 all the way through, it gives us -1.5 or $1.50 minus C equals -400. And then I'll rewrite that top one. H plus C equals 295. Then we go ahead and draw our addition line, add, and we get -1.5H plus 1H is -0.5. The C's will subtract out, and you get -105 here. Then to solve this, we divide by negative 0.5, and H equals 210. So that means they sold 210 cups of hot chocolate. To find out how much coffee they sold, I'm going to go back to the top equation, the H plus C. And I know H ended up being 210 plus the C equals 295. And to solve this, we subtract 210 from both sides. And C equals 85. So again, one of the things you have to do is interpret the solution. So this says that the drama club, I'm going to say they sold 85 cups of coffee and 210 cups of hot chocolate. Alright, that should take you to your assignment, which is solving systems of equations by elimination. Good luck.